Hi everyone, my name is Andro and today I'm going to present you guys about the general theory of video compression, especially about computing motion factors. Before we start, let's take a look at this footage. Now, let's take two frames to get the idea of the motion factor. The first frame will be the frame n and the second frame will be the frame n plus 1. The two straight line between the two frames shows the position of first macroblock, which is the collocated pixel in frame n that has moved to a new location in frame n plus 1. The offset between the two positions is called the motion factor. So, motion factor is a two-dimensional factor used for interprediction that provides an offset from a coordinates in the decoded picture to the coordinates in a reference picture. Motion factor is a key element in the motion estimation process. It is used to represent a macroblock in a frame based on the position of the macroblock or a similar one in another frame called the reference frame. The difference between the most similar regions between the target frame and the reference frame gives the motion factor. This difference is also called as the residual frame. In a video encoder, the present frame will be subtracted with the previous frame and it produces the difference frame. In the video decoder, the difference frame will be added with the previous frame and it produces the present frame. Couldn't we just take the original frame instead of using the residual frame? We could, but the residual frame has much less information and it is highly compressible, so it can minimize the video size. Let's now see the full process of the video encoder. First, the frame n will be taken for motion compensation process and it will also be used for subtracting the next frame, which is frame n plus 1, to produce the difference image or residual frame. The residual frame will be compressed using JPEG-DCT, quantization, and entropy coding, so it will produce the encoded image. At the bottom process, the motion factors will be encoded to produce the encoded motion factor. In the video decoder, the encoded image will be decompressed using JPEG entropy decoding, dequantization, and IDCT. So it will produce the residual image. The encoded motion factors also be decoded, and the frame n will be used for reconstruct frame n plus 1 using the motion factors and adds the residual frame to get the final frame n plus 1. So how does the motion factor search works? The goal of the motion factor search is to find the best matching area in the reference frame to the target macroblock out of all candidate macroblocks in the search region. The encoder needs to search the best match for macroblock in frame n plus 1 from frame n. The search is performed within a search area specified by parameter k around the collocated position. The best matching area that is obtained in the search gives the motion factor. After knowing how the motion factor search works, now we need to know how it is calculated. The difference between the candidate area and the target block can be calculated by their mean absolute difference, MAD, defined as this function. M is the width of the macroblock. N is the height of the macroblock. Cn plus 1 is the target macroblock. Cn is the reference macroblock. P and Q defines the pixel of the macroblock. I and J is the motion factor where value is vary from min k to plus k. We need to calculate this MAD because the goal of the search task is to find a motion factor ing where the main absolute difference is minimum. Although MAD are commonly used, other metrics have been proposed in motion compensation literature. Some of these are known to give better search results, but more cost because of the additional competition. The other metrics are mean square difference MSD, file difference classification, and projective ordering. But again, we can see that these metrics have one thing in common, which is calculating the difference between the target block and the reference block. Here are some demonstration of motion factor using VC demo. The top left window of the screen is a raw video that is provided by the VC demo. The top right window is the frame difference. The bottom left window is the factor field, and the bottom right window is the motion factor or the motion compensation frame difference. And the bottom right window is the motion compensation frame difference. So by seeing this demonstration, I hope you guys get the idea of motion factors. In this section, I will talking about the benefits of multimedia system in daily life. So, what is multimedia? Multimedia can be defined as any application that combines text with graphics, animation, audio, video, and or virtual reality. Tools that provides this multimedia consist of hardware and software. The example of the multimedia hardware are microphone, camera, camcorder, pen tablet, and VR controller. The example of multimedia software consists of text processing such as Microsoft Word, image processing such as Adobe Photoshop, audio processing such as Audacity, and video processing such as Adobe Premiere Pro. Why multimedia is used? Multimedia is used because it plays a crucial role in our life, especially in today's world of technology. Multimedia influence every aspect of human life because we can use multimedia to express our thoughts and ideas to others in a better way. Where multimedia is used. Multimedia finds its application in various areas including advertisement, art, education, entertainment, industry, engineering, medicine, mathematics, business, scientific research, and many others. Some of the examples are advertising industry that uses multimedia to advertise businesses, products, and services to customers. Entertainment industry that use multimedia to make music, movie, and video games, and also educational field that used multimedia to increase the effectiveness and productive learning method using presentation, video course, and interactive quizzes. Who benefits multimedia? It could be everyone who uses multimedia in their lives, such as for work, study, and doing scientific research. But there is the one who really gets the benefits of this multimedia, that is a person who are really exposed to the multimedia itself, such as content creator, videographer, graphic designer, illustrator, and other multimedia fields. When multimedia system is used, multimedia system is used when we create, modify, edit, doing compression, or just playing the multimedia itself. Such as when we create a video, we use H.264 standard to encode the video into a compressed format. When we want to play the video, the decoder converts the compressed video into an uncompressed video file so we can play it through various video players. How multimedia system benefits us. Multimedia system gives us benefits in many ways. Multimedia system not only let us to combine text, graphic, audio, and video, but it also gives us ways for doing compression to get less file size, but yet still maintaining the quality itself, such as compressing text using Huffman coding, compressing graphic using DCT, quantization, and entropy coding, compressing audio using psychoacoustic, and compressing video using block-based prediction and motion compensation. All of that kind of compression are now commonly used in today compression standards. However, compression is still an active area of research. Just think of using machine learning models to improve the performance of compression. It could really optimizing the multimedia quality while minimizing the file size. So this will end the video. I hope you liked it and thank you for watching.